Alright, today we're going to talk about quadrilaterals. So the word quad means four, laterals means sides, so four sides. We're going to start talking about the most general type of quadrilateral. So it is this one. Okay. The most general type is, of course, just called a quadrilateral. So there's nothing inherently special about that. It just has four sides. So from here on out, we're going to start classifying these by the number of parallel sides that they have. Okay, so there's only two possibilities. The first possibility is that it has one pair of parallel sides. So this is the symbol for parallel. Okay. And then the other alternative is that there's two pairs of parallel sides. So let's talk about having one pair of parallel sides. So when you have one pair of parallel sides, okay, indicated by these two arrows here, that these two sides are parallel, you have what is called a trapezoid. Or if you're from another country, trapezium, but you're not. You're in the US. Trapezoid. So if this trapezoid has one pair of congruent sides, like this one, okay, you get an isosceles trapezoid. Okay, so an isosceles trapezoid is definitely kind of trapezoid. Okay, but a trapezoid isn't necessarily an isosceles trapezoid. So you have to remember that there's a certain hierarchy here. So moving on to the family that has two pairs of parallel sides, well, our most general quadrilateral with two pairs of parallel sides is called a parallelogram. So parallelogram you might think of as a slanted rectangle. So it has this pair of congruent sides and these two pairs of congruent sides. So moving on down, now we have two options. Either they have two pairs of congruent sides, in which case you get in 90-degree angles, in which case you have a rectangle. So a rectangle is a type of parallelogram, which is in turn a type of quadrilateral. So moving on to the next branch, if we have all congruent sides, and angles that are not necessarily 90 degrees, okay, we have a rhombus. So you can think of this as a slanted square. So let me write here, and angles that are not, and the key word is necessarily. So here we have a rhombus. Okay, some people might call this a diamond, but we're going to stick with the word rhombus. So if we force the angles to have to be 90 degrees, we of course get a square. So, just to put this into perspective, okay, now we have this big family tree here. Okay, a square is a type of rhombus, which in turn is a type of parallelogram, which in turn is a type of quadrilateral. So a square has all the properties of the family that goes above it, okay, on the same branch. However, okay, it is not correct to say that a rhombus has to be a square. But it is correct to say that a square is a type of rhombus. Same thing as saying that a square is a type of parallelogram, but a parallelogram is not necessarily a square. So just to recap on this, so let's say, so in terms of classifying, ooh, it's too small. Let me just write it. So in terms of classifying them, okay, we typically move in general. So we moved from the general classification of quadrilateral to the most specific. So the most specific would be the square. Has a lot of properties. No, specific, not square. The other thing is that it's customary that's it's customary to use the most specific name for a shape. Specific name for a shape. So I'm not going to sit here and keep calling this square a parallelogram. So if it's possible, you should always use the most specific name for the shape. So this is the basics on how to classify quadrilaterals. Okay, in our next lesson, we're going to be talking about the properties of the diagonals of the quadrilaterals.